Right, so can you guys see my screen now?
Yes, sir.
Yes, sir.
All right, so this is where we've stopped. So any questions so far regarding with the slide?
Wala naman po, sir.
All right, so the next one is arithmetic or summation formula. Okay, so there is actually an explicit formula for the previous example. Okay, so for you to be able to get the summation, this one, so starting from 1 up to the given uh, maximum limit or upper limit. So you have this formula. So as you can see, this one is also quite familiar. Okay, we already uh, had this formula on the, I don't know if it's module 2 or module 1. Anyway, so we have already uh, defined this one using inductive. Forget the name. Anyway, so yeah, this is the explicit formula for you to be able to get the summation from 1 up to the given n. So take note, this one is only exclusive, okay, if it's starting from 1 up to, uh, let's say 100 or 200 or up to its range. But if your I is equal to 2 or 4 or 5 or 20 up to, let's say, 100, then this formula is not applicable anymore. Okay, so it is only applicable if your I is starting from 1. Okay, so from there you will be able to get the summation of that given uh, example or that given range. So in with reason, the smallest term is 1, okay, which is always 1 when it comes to this formula. So the biggest term is n. Okay, so the average term is n plus 1 divided by 2. Okay, so this is the formula on how to get the average, okay, of that given range. Okay, so were you guys able to follow this one? So as of now, this is the first formula that you have to memorize when it comes to summation. So again, this one is only explicit for starting from 1. Okay, so you have to memorize the one. So n times n plus 1 divided by. So are we clear so far regarding with this one?
Yes, sir.
All right. So this one is actually not complete yet. Okay. For you to be able to obtain the final form in having a summation, okay, let's say from 1 to 10, okay, just multiply the average from the or from this formula, okay. So n minus m plus 1, and then this n plus m divided by 2 is actually this one. Okay, so your m here is your lower limit, which is always 1. Okay, so you can say that this one is n plus 1 already. Okay, coming from here, n plus 1 divided by 2. Okay, so you have this formula, and then you have to multiply this one to the average, okay, by the number of terms. From here, just by applying this formula, okay, then you will be able to get the summation, for example, from 1 to 10. Okay, so what is estimation from 1 to 10? So just follow this formula. So n minus m plus 1. Okay, so 10 minus 1 plus 1 times 10 plus 1 divided by 2. Then just do the math, and then you will get 55. Okay, all right. And then, since we already have this wherein it is not limited by 1 anymore, okay, so it could start with 3 already, right? So from here, just the same format, okay, just follow this format, okay, or this formula. So n here is uh 6, and then your m here is 3, and then plus 1. So 6 minus 3 plus 1 is 4. And then just do the math in here. So 6 plus 3 is 9 divided by 2 is 4.5. So 4.5 times 4 is equal to 80. Okay. So you can use this formula, okay, if it's only ranging from 1 up to the given limit. But this one is much more flexible. So this is the easiest way if it's starting from 1. But if it's starting now from 2, 3, 4, 5, and so on and so forth, then you have to use this formula now. Okay. So just memorize this one. So n minus m plus 1 times n plus n divided by 2. So are we clear so far?
Yes, sir.
Right, so I'll just repeat. So use this formula if it's ranging or if it's starting from 1. And then use this formula if it's starting from any number actually. Okay, could be 1, could be 3, could be 5, and so on and so forth. All right. So we have here arithmetic summation example. Okay, this is example number 1. So evaluate the following using arithmetic summation formula. Okay, so we have here the starting point is 20 up to 103. And then we have this given formula, 5 times I minus 3. Okay, so you cannot just substitute the value of I here right away. Okay, so we have this given, step-by-step solution on how did we come up with a more elaborate uh, formula. Okay, so here's the solution. So initially, we just copy this one. Okay, nothing happens, and then we bring out this 5 to this summation. So as you can see, it's now 5 times summation I times I minus 3. All right. Then after that, we've now have this formula. So 5 times summation I minus 5 times 3. So basically, we've just separate this I and then this negative 3. Okay, so it's like distributing this 5 from outside and then separating the 3 at the same time. So I know this one is quite confusing. Okay, well anyway, I have a backup for this one, which is the longer method. Okay, so for now, I will leave this one to you and how did we come up with this kind of formula. Okay, because this one is basically algebra. Okay, and then this is already final format. Once you have already eliminated the close enough and parentheses, then you can now proceed and then start substituting their values. So here, 5 is still 5. And then this summation here is actually the n plus m minus n. N minus m plus 1. Okay. So n minus m plus 1. So just follow that one. You will get 100p minus 20 plus 1. So 103 minus 20 is 83 plus 1, 84. So this is our 84, wherein we have 84 or a total of 84 terms times this letter I. So what is this letter I? This is the n plus m divided by 2. So as you can see, this summation I by default, okay, is this one. Summation I, or this summation is the n minus m plus 1, and then this I is n plus m divided by 2. Okay, so one formula and then another formula, which is now this one. So were you guys able to follow up to this point?
Yes, sir. That's known.
So where this 84 came from, this is the n minus m plus 1. Where is this 103 plus 3 divided by 2 came from? This is the n plus m divided by 2. And then just keep on following this one. So minus 5 times the summation, wherein it's 84. So in here, they just interchange. So times 84, and then the last one is times 3. Okay. Wherein if you're going to solve this one, you will get 24,570. Okay. So that's how you simplify, or that's how you call this one. Mm, yeah, I think simplify. There's no other term that we can indicate for this one. So that's how you simplify this formula to get the total summation from 20 to 103, which is 24,570. So if you wasn't able to understand this one, then we have this solution number 2, okay, which is just the same result, but a different way of solving it. So again, same question, of course. So evaluate the following using arithmetic summation formula. So we have this 20 to 103 and so on and so forth. So the same. So if you're going to substitute 20, which is your first term, which is the a sub 1, so you will get 85. So 20 minus 3 is 17. 17 times 5 is 85. And then for the second term is 21, of course. So 21 minus 3 is 19. Yeah, 18, sorry. 21 minus 3 is 18. Times 5 is 90. And then 19 minus 3 is 19 minus 3. No, no. 22 minus 3, sorry, is 19. Times 5 is 95. And so on and so forth. Okay, so as you can see, this one is incrementing by 5. So 85, 90, 95, up to a sub n. Okay, so as you can see right here, the maximum number is 103. So 103 minus 3 is 100 times 5 is 500. So that is our given sequence. So 85, 90, 95 up to 500. Okay. So for you to be able to get this 24,570, you have to know this formula. Okay. So this is the formula on how to identify many terms in total. So a sub n is equal to a sub 1 plus n minus 1 times d. Okay. So this is actually the longer format. Okay. I've just indicated it in here just in case you want to have a longer solution. But as you can see, if you're going to get the total terms for this one, you can actually use this one, n minus n plus 1, okay, which is just the same. Anyway, since it's already in here, so we will use this formula for us to be able to identify the total terms of this given number. So d here is the difference. And then e sub n is the maximum number. E sub 1 is the first term. And then n minus 1 is just in there. N is actually the total term. So just copy as it is and then substitute the corresponding values. So e sub n is, just leave it as it is for now. E sub 1 is 85. Okay. And then plus n minus 1. So d here, so as you can see, what is the difference from the second term and the first term, and then the third term, and then the second term? So as you can see, this one has a difference of 5. So just put here 5. Okay, and then distribute it. So then we can now simplify that a sub n is actually 500. Okay, is equal to 85 plus, so just distribute this one. So 5n minus 5, and then just simplify it a little bit more. So 85 minus 5 is 80 plus 5n. And then just transpose this 80 on the other side. So it will become now negative 80. So 500 minus 80 is equal to 420. And then for you to be able to get the n, so just transpose this on the denominator, okay, or cross multiply. Okay, so for 20 divided by 5 is equal to 84. So as you can see, we have a total of 84 terms out of this range. So from 20 to 103. Okay. So once we already know what is, or yeah, what is a total term, which is the same with this one, n minus n plus 1. Then you can now proceed and then use this given formula. Okay, so a sub n is equal to n divided by 2 times a1 plus a sub n. So just substitute the corresponding values. So n is 84 divided by 2 times a sub 1 is 85 plus a sub n is 500. So 85 plus 500 is 585. 84 divided by 2 is 42. So 42 times 585, then you will get 24,570. Okay, which is the same with this one. All right. So I'll let you guys verify this one. Then let me know you have already understood it.
Understood naman po.
Understand?
Yes, sir.
How about the others?
Naintindihan naman, sir.
May naman parang 50-50 yun All right, so you have two ways. So it is either you call this one. So it is either you simplify this formula or you can use those two formulas instead.
Sir, pero pwede gamitin yung naunang formula.
Yeah, you can use any of those two. So it is completely up to you.
Okay, sir.
All right. So once you're done in understanding those given examples and concepts, so you're going to have a seat break, of course. So this is your seat break number 3. So evaluate the following using arithmetic summation formula. So your starting number is 25 up to 50. So here's the formula. So 3 times 2i minus 5. And for number 2, so starting from 2 to 8, so identify the summation if we have this formula. So 2 times 5 plus 2i. Okay, so you can either use this one or this one. So are we clear so far?
Yes. Yes, sir.
How about the others?
Medyo
Yes, sir.
clear naman, sir.
Medyo. So I like that honest answer. So it's okay since, this is actually a fast moving lesson, okay, or fast moving discussion. So that is why you have a lot of time to answer these given seat breaks. So you always have 1 week to finish everything. Okay. All right, so this is your seat break number 3. So as usual, you can do this one handwritten and then just upload it on our canvas. All right, so if we have summation, we also have geometric summation formula. Okay, I'm sorry, we have arithmetic summation. We also have geometric summation formula. Okay, So geometric sum is a sum of portion of a geometric sequence and has the following explicit formula. Okay, so by default, we have this given formula already. Okay, so summation is ranging from 0 to n. So a times r raised to I. So as you can see, we are still using summation. Okay, so this one is the same with the geometric or the notation. Okay, so this is how you for this one elaborate that given notation symbol, and then by using this summation, then you can have the geometric sum of that given formula. So from here, as you can see, we will start with 0. So just substitute this one here for you to be able to get the first term. So any number that is raised to 0 is equal to 1. So a times 1 is a, which is now this one. And then of course the next one is 1. So r raised to 1 is r. So just add as it is. So a times r plus a r raised to 2, and so on and so forth up to raised to n. Okay, and then we have this explicit formula. Okay, wherein this one is actually the same with this one or equal with this one. Okay, so a times r raised to n plus 1 minus a divided by r minus 1. Okay. So if it's starting with 0, then you can use this formula. All right, so for now, I'll leave the memorization part until you later on. So for you to be able to understand this one a little bit more, we have this example. So evaluate the following using geometric summation formula. Okay, so we have here starting from 0 and then up to 13. Okay, and then we have this given formula, so 2 raised to I. So you can either use this one or you can do it manually. Okay, since there's only 13, actually 14 terms. But you know, why make it longer when we have the shorter solution? So just use this formula, okay, wherein this substitute their corresponding values. So a here is 2. Ah, sorry. A is equal to 1, okay, and then r is equal to 2. Okay, so apply this by using this geometric formula. Okay, so n minus 1 or n plus 1, sorry, is 14 since your n here is 13. So just add 1, then you will get 14. So if you're going to apply or if you're going to use this given formula, you have to use these values. So by default, a is equal to 1 and then r is equal to 2. So 1 times 2 raised to 14 minus 1 divided by 2 minus 1. Okay. So just simplify this one a little bit more, then you will get 2 raised to 14 minus 1. Then just solve this one using your calculator, then you will get 16,383. So that's the geometric sum from 0 to 13 having this formula. Oops, I'm sorry. So this one is not a constant or a fixed value. Okay, this one came from this formula. So your r here is 2, and then your a here is 1. Is it? Wait, I'm the one now who's confused with what I made. So apply geometric function of the setting a is equal to 1 and r is equal to 2. So 2 raised to I is equal to 2. 1 times 2 raised to n plus 1. Oh, yeah. So I think this one is a fixed or a constant value when it comes to using this formula. So we will verify later on if this one is a fixed or a constant value. Okay. So I'm not sure anymore if this one came from this formula because R here is 2, and then where this one came from because we've started with 0. So it's 50-50. So we will verify this one later on. But for now, just use this given value. So A is equal to 1 and then R is equal to 2 when it comes to using this given formula. And then take note, you can use this given formula as long as your I starts with 0 up to letter N. Okay. So the same with summation a while ago. So you can use an explicit formula as long as it's starting with 1 up to N. But if it's starting with 3 and so on and so forth, then you can use the other formula. So were you guys able to grasp the idea regarding with this formula? Hello? Are you guys still there? So the only confusing part is this one, okay? The values of A and then R. So we will look whether this one is really fixed or no on the following examples. So for now, just follow this formula if we have a starting from 0 up to letter N. So are we clear so far?
Yes, sir.
Yes, sir.
All right.
Yes, sir. Yes, sir.
So let's now proceed to the next one, hoping that we can solve this confusion right here. All right. So we have this geometric sequence. So the terms of a geometric sequence have the form of a sub I is equal to a times r raised to I. So for summation, we only have a sub I, or sometimes this is just only I. But in geometric, okay, we have this additional, or a revised version actually. So instead of a subscript, we have here a superscript or an exponent. And then we have an additional variable wherein r here is, where is that one? R, ano, I didn't indicate what is R in here. Anyway, A here is formula, and then R here is also a part of that formula, where A is the first term, okay, when I starts at 0. So as always, this one is the value of the first term if we have a given 0 for the starting point. So for example, we have this one. So what is A and R in the geometric sequence? So 2, 6, 18, 54, 162. So what do you guys think? What is our A? And then what is our R? So A is very obvious. So A is the first term. So A is 2. And then what is our R?
Sir, last term.
Yes?
Sir, yung last term.
Ano yan? Hindi ko masyado marinig.
R should be
Sir, yung
3.
last term.
What is that? Mr. Followe? I don't know if it's Mr. Gonzalez or Mr. Followewa.
R should be 3.
How you should do it? Just by applying his formula. Okay.
Yeah, I said R is 3.
I'll is do it.
Yes.
Yung R daw po is 3.
I is 3.
Yung R po, 3 daw.
R is 3. I'm sorry. Okay. Someone chat. So, sir, last term. No. R is not our last term. So basically, this is just our multiplier for you to be able to get the next term. Okay. So for example, you have raised to 0, right? So this is your first term, which is 2. So 2 times 3. So we will put here 3 since this is the assume next value. It's just multiplied by 3. Okay. And then raised to 0. So any number that is raised to 0 is 1. So 2 times 1 is 2, having now the first term. And then if we have the second term, which is now raised to 1, so 2 times 3 raised to 1 is 6. And then getting the second term is 2 times 3 raised to 2, wherein you will get 18. Okay, and so on and so forth. So A here is 2, and then R here is 3. I here is already given, so as always, you will start with 0, and then incrementing by 1. So raised to 0, raised to 1, raised to 2, raised to 3, raised to 4, and so on and so forth. Okay, so that's how we've got the value of A and R, right? So we have this given solution. So I thought I wasn't able to put the solution. So here, so what is A and R in geometric sequence? So the same question, and then the same kind of solution, which is this one. So A sub 0 is 2, and then A sub 1 is 3. Why A sub 1? A sub 0